in excuse me, there's a random function in Excel that you can enter in all the numbers, and you enter in all the numbers and it'll randomly select some, and then you just put in 5 spaces and the amount of numbers you want it to go through, and it'll randomly select 5 for you.
Oh, okay.
I didn't explain that very well, but at the top you just write R-A-N-D and put the numbers, and you just let Excel do it for you.
Oh, gotcha. I didn't know you could do that. Okay, so B.
Excuse me.
Okay. What else did you want to go over on part 2?
Hang on. Seven. Excuse me. Wish I didn't work during the teacher's office hours.
Yeah. When's the teacher's office hours?
It's usually like Friday at noon, Idaho time.
Oh, really?
So for 7A, it's what is the mean of your sample? Isn't that just a regular mean? You just take whatever your sample was and find the mean.
Yeah.
All right.
Like I did.
Did you have like a huge number?
What was your number?
I had 189,100.
I had 43,260.
So I probably.
All I did was I added all 5 of them together and then divided by 5.
Uh-huh.
I thought that's how you found the mean.
Yeah, that is. I'm looking at my number thinking it's a really big number.
That is a really big number.
I wonder, because it's just written here, I wonder if I didn't divide it by 5.
Try dividing it by 5 and see what you get.
37,820. That seems more reasonable.
Yeah, it does.
Yeah, I think. Hang on. Hang on. Yeah, I wrote down my number, but I didn't divide it by 5.
Okay.
All right, so that's my mean.
Okay, and then
Did you just do B in um, SPSS or Excel, or did you do it by hand?
I just did it by hand. How did you do it?
Um, I did it by hand, but I wasn't sure if we could do it in one of the programs
I
to
don't. I
to
don't
like
think
save
so.
time.
I don't think so. I think if we could have, it would have said.
Oh, that's a good point. It's been doing that. Like they actually say when we can do it by hand.
Okay,
All right, so here's where the hang up on C. How do we decide if it's usual or unusual?
that's what I was just about to ask you.
Dang it! I was hoping that was something that you understood. I have my chapter open right now, and I was reading through it, and I really feel like reading the textbook for this lesson makes me even more confused.
Yeah, this was a challenging lesson.
So I have my textbook open right now to where it says, "When is X bar normal?"
And what does it say? Because I read through that last night and I can't remember what it says now.
If the parent population is normal, then the sampling distribution of X bar will always be normally distributed, no matter how many observations are selected.
So it's normally distributed. So
But our parent population is the
is the what?
oh, I was reading our sampling because our parent population are the 30 that number like the 30 pieces of paper we chose from, right?
Uh-huh.
And how do so and they're how are we supposed to know if they're normally distributed because they're all above 30? Because if a parent population is heavily skewed, then it will require a larger sample size to be assured that X bar will be normally distributed. For most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large to assure that X bar will be approximately normally distributed. And it is. We had 30 that we chose from. There were 30, and we randomly selected 5.
Yeah. So, so does your sample mean appear to be unusual? I would say no, because the sample or the parent population size is 30 and it's normally distributed. That's what I would say.
That's what I put, but I was hoping to understand it better. Reading this again in the morning is making more sense than it did last night at midnight.
Yeah.
For tremendously skewed distributions, the distribution of lottery payouts, a much larger sample will be required before the distribution of sample means is approximately normal. This may require billions of observations. Simulation can be used to determine if a particular sample size is sufficient. For this course, if the sample size is at least 30, we will conclude that the sampling distribution of X bar will be approximately normal.
Okay. So yeah, it's basically telling us that. Oh, hang on.
So we know it's normal if the sample size is large or the parent population is normal.
Yeah. That's what I'm understanding from it, at least. And that's kind of what he went over in the video that I watched last night, too.
See, this is where my brain starts saying what is when the vocabulary says the mean of the sample means is mu. I do, the, I'm reading this in the text.
Well, the mean of the sample means. Hmm.
The mean of the sample means is that symbol, the backwards U.
Oh, yeah.
The standard deviation of the sample means is sigma divided by the square root of n. So
Yeah.
n is the sample. Standard deviation divided by the square root of the sample n.
Yeah. Yeah. That's how you do number 9 on the form.
No wonder. I'm going over the things that I don't understand, and no wonder that's the one that I needed for the,
Yeah.
for the one I can't do.
But
Think about the simulations you've observed. The mean of the sample means was always aligned. Also, if you look at the samples larger than n equals 1, the standard deviation of the sample means was always smaller. Alright, so number 9, where did it go? There it is. Alright, number 9 says, what is the standard deviation of the distribution of sample means? So did you just put 1?
yeah, that's what I got. It says 3 decimal places though, so should we put like 1.000? Or do you think it doesn't matter?
I don't know.
I don't know either.
Alright, so I put number 1 for that. So number 3, when taking samples of n, when n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? Would the answer be right skewed?
That's what I put.
Or excuse me, the answer would be skewed right. I don't.
That's what I put. I mean, I feel like they kind of give us the answer in the question.
Because the sample's only 5, so we know it's not normal.
Yeah.
And the parent population is right skewed, so the parent population is not normal. So if the parent population's right skewed, then the distribution of means will be right skewed.
Yeah.
And then number 4, I put normal because the sample size is 100 and the parent population is right skewed.
Why'd you put normal?
Because we have the two different things. If it's normal, if the sample size is large or the parent population is normal.
Okay.
Do they both have to be the same thing? Sample size is large and parent population is normal, or is it just one of those things?
Hang on. Let me look.
Because it has to be both. Obviously, the parent population is right skewed.
Okay, it says if the parent population is heavily skewed, then it will require a larger sample size to be assured that X bar will be normally distributed.
And we have a sample size of 100. That's
with a
significantly
large
bigger
sample
than
size.
30.
Yeah. So yeah,
So I think it's normal.
yeah. And then 5, I put normal for 5.
Yeah, well, that one's easy too because the parent population is normal and the sample is normal.
Yeah.
Okay, so I have normal.
Okay. Okay. What did you put for 6?
I think it's all of them except for the sample size is small. So data are all of them except for data are drawn from a population that is right skewed and the sample size is small because that's both of the criteria that we can't use.
Yeah.
Because it's either both or one or the other, but you can't have because it's the distribution it be normally that's what we were just talking about. For it to
Yeah.
be normally distributed, it has to either have a sample size that's large or parent population that's normal. This one is this is a sample size that's small and a population that's right skewed. It's not normal.
Yeah.
But then with the other one, you have um, a population that's right skewed, but the sample size is large, and
And
then you
that
have
was it.
normally distributed and large or small, but you still have it normally distributed.
Yeah. Okay.
Because as we were just talking about, unless I'm wrong
Guess we'll find out.
from what we just talked about, which
Okay.
which makes me because uh, that would be why
Normal.
number
Yeah.
three
Or
is
skip right. I'm sorry.
that would be why number 3 is skewed right because the um,
The sample is
the sample's
small.
small and the population's not normal.
Yeah.
That's what that is. Data are drawn from a population that's right skewed and the sample size is small. That's exactly number 3.
Okay. That makes sense. Okay.
Uh, okay.
What
What'd
do
you
you,
get for number 7?
okay, I put if the sample size is oh wait, hang on. Okay, I put if the sample size is large, the shape of the sampling distribution of the sample. Oh, did I do that wrong?
That's what I put.
Okay.
The shape of the sampling distribution of the sample mean X bar will be approximately normal.
Yeah, that's what I put.
Well, either we're both understanding the textbook correctly or we're both understanding it wrong.
Yeah.
Uh,
Hang on.
I'm reading through the text right now just to make sure.
Yeah, because it says the sampling distribution of the sample mean will be approximately normal if the sample size is sufficiently large.
Yep, it's just explaining central limit theorem in
Yeah.
weird. Let X be a random variable with population mean 10 and population standard deviation 6. Suppose a sample size of 36, which is large, is drawn from this population. What is the mean of the distribution of sample means?
Isn't it
So
isn't it just 10?
that's what I thought because that's what I was reading to you. The mean of the sample means is that symbol, so that would be 10.
Yeah.
I think they're just trying to make it complicated.
I know. And I watched the video last night and it went over this too.
So the way they phrase the question, it makes me want to put it into a formula,
Mm-hmm.
but I
But
don't know. But I looked in the textbook and I didn't see a formula to put it in.
no, I'm pretty sure it's just 10.
That makes sense. And then number 9 would be 1, and number
Mhm.
10 is normal, and 11 is central limit theorem.
Yeah.
Oh, I'm so not gonna look forward to doing the homework quiz.
I know. I think I need to
I
take a
can't
nap.
believe we have a test on this next week.
I'm really stressing out about this test.
I feel like we need to go over starting back at lesson 2.
Yeah, we should have a review or something before the test.
We need to quiz each other is what we need to do.
Mm-hmm.
Like,
Okay.
come
I'm
up with our own review.
yeah. I'm going to submit the quiz.
Alright, so for number 3, I put skewed right. Number 4, I put normal. 5, I put normal. 6, I have we discussed that in length. 7, I put if the sample size is large, the shape of the sampling distribution of the mean X bar will be approximately normal.
Mm-hmm.
8, I put 10. 9 is 1. 10 is normal, and 11 is central limit theorem.
Okay, yeah, that's what I've got. All right. You ready? I'm nervous. Okay, we gotta